release them. I grind cause I gotta get paid. 1% chance, 99% faith. I fell in love with the hustle, I fell in love with the chase. No emotion, put in the pain. We get it no matter the weather. Sun, snow, sleet, rain. Go sleep and do it again. My heart been telling me yes, mind been telling me no. Lockdown, I've been inside. Long time I ain't been on my home. When they call, don't answer the phone. I just wanna be on my own. I get up and get in my zone. All of these empty promises, it's like I don't know what's real. Everyone turn out fake, and now I don't know how to feel. I'm in the driver's seat, I can't control the wheel. We can split everything else, but no, we ain't splitting the bill. Let's see how far it can take me. They say I'm a blow, never say how long it will take me. But I'm on the way, just wait me. I thought she was done with me, now she said that she can't replace me. My heart been telling me yes, mind been telling me no. Lockdown, I've been inside. Long time I ain't been on my home. When they call, don't answer the phone. I just wanna be on my own. I get up and get in my zone. My heart been telling me yes, mind been telling me no. Lockdown, I've been inside. Long time I ain't been on my home. When they call, don't answer the phone. I just wanna be on my own. I get up and get in my zone.
No one checked on me when I needed, so I just stack my bread, stay in my bag and not in my feelings. Overthink too much, I get distracted, start to deep it. I just deal with people exactly how they treat me. On the block ain't nothing but youths, trying to be bad and hoes that act up. I've been obsessed with money, I knew would get my stack up. I ain't lacking on my own, I got me, no backup. They talking on me, and none of it factual. Meanwhile, bro in a bando, hoping Fed don't raid his yard. She like, boy, you toxic, you ain't got no heart. Get let down when you love too hard. 100 roses ain't gonna fix it. Maybe a Chanel bag. No one checked on me when I needed, so I just stack my bread, stay in my bag and not in my feelings. Overthink too much, I get distracted, start to deep it. I just deal with people exactly how they treat me. Don't bell my phone, I'm busy. Not right now, I'm busy. I'm not outside, but after I make this play, I'll go get litty. Bad B still wanna link me, but guess what? Not today. Try block my shine. Bro, get out the way. You man beef ain't got no income, that shit dead to me. I know that hoes still want a reaction, you lot be tempting me. so I'm not even talking. You want my ETA, I ain't left just yet, I'm stalling. Still gonna come through, shake that back, still gonna eat me up like Marley's. I just get paid, I'm boring, nowadays I shoot, I'm scoring. I CBA, so I'm not even talking. You want my ETA, I ain't left just yet, I'm stalling. Still gonna come through, shake that back, still gonna eat me up like Marley's. I just get paid, I'm boring, nowadays I shoot, I'm scoring.
How's man talk about pressure? I don't feel pressure. Send a text on the chat line, give out some testers, then back to my leisure. I got bro to the end card, that's my brother, that's my brother, that's my brother. I ain't got no gun, but if I cop that dots, bury it like treasure. Ayy, born in the east side, could've been a daily offender, crazy extender. Might see me in the west with the gunners, or see me with Cahill like Arsene Wenger. Big spender, thought he was a spender, done all the spending stop. Thinking the man, come to the block, can't take out your chain when your shit get popped. No art, can't really rock on my block. I hit so many shots on my block, I sit my Henny, don't need the walk. Got cats like Wonder Mad for the rock. Pressure. Ain't been around for a while, but it's calm cause the crowd go mad when I enter. Still break down bricks like Jenga. Chop that. No art, can't really rock on my block. I hit so many shots on my block, I sit my Henny, don't need the walk. Got cats like Wonder Mad for the rock. Pressure. Ain't been around for a while, but it's calm cause the crowd go mad when I enter. Still break down bricks like Jenga. Chop that. Hey, cats keep calling my phone, man, leave me alone, I'm grinding. I woke up this morning smiling, haters trying to bring me down, I don't know why. Niggas out here still in flow, trying to keep it on the low, for they did it on the slide. Stepped in the function with a bottle of Henny and the crow, and I did it for the vibe. Push back and I did it with the guys, done it with the green, bro, did it with the rice. Done it with the text, bro, done it with the Rex, sold everyone a dream, and I did it with a lie. Little man, you don't wanna live this life, outside with your kitchen knife. Till things get hot on the block and this shit goes left, all you need's advice. How's man talk about pressure? I don't feel pressure. Send a text on the chat line, give out some testers, then back to my leisure. I got bro to the end card, that's my brother, that's my brother, that's my brother. I ain't got no gun, but if I cop that dots, bury it like treasure. Ayy, born in the east side, could've been a daily offender, crazy extender. Might see me in the west with the gunners, or see me with Cahill like Arsene Wenger. Big spender, thought he was a spender, done all the spending stop. Thinking the man, come to the block, can't take
Just saying, I'm loving what I'm saying for me. Don't give a fuck. Anyone, I know what you need, baby. Listen to me speak. Don't give a fuck. Just saying, I'm loving what I'm saying for me. Oh shit. Don't give a fuck.
Mason.
Lately I've been ghosting, getting my bread up. I nearly forgot I could rap. It's 4 a.m. right now. I ain't had no sleep on my way trying to write me a track. And bro really should've kicked ball like Foden, but he's OT, serving crack. Never had P, swear no cap. We're just trying to move far from the council flats. I've been living 2 lives at Hannah. Bro so stuck in a dusty trap, couldn't care about the glitz and glamour. I ain't trying to die young like Roddy, so Brody I might buy me a hammer. They might take my life, so I gotta watch out when I step in a manner. I nearly forgot I'm a rapper. Life ain't sweet when you're raising hell, bro. Been heartbroken on numerous occasions. He found love with the dots and shows. Let me tell you a fact, only time that he's ever been cuffed, he was sitting in cells. He can never put faith in girls, he'd rather get thrown in jail. He'd rather get thrown in jail. Life ain't sweet when you're raising hell, bro. Been
Binary search on maximum throughput. If you can afford to make every service throughput greater than or equals to 1000, you can definitely afford to make them all 900. So this yes no property always allows us to binary search for the highest value X or target throughput for which the answer is yes, it's possible. Okay, it was Y, and no. And you have to find the last Y, and in which Y you can afford to make every service throughput greater than something. But will it take, will we have to pass through the whole vector, um, whole vector once more? Or is there a better way to do that? Or is there a better way to do that? Yes, no property, yes, it's possible. The can achieve target function. Um, this is the code of our solution. We need a function that answers, can we make all services have at least target to give us our budget? So initially, then our target is 35. The formula for operation needed is target minus 1 divided by throughput of 5. Oh, I didn't know that just by doing minus 1 you get such good things. Mm, to get from one value to another, how many times do you have to multiply? If it is odd, um, if it is 35, 34 by 10, which is 3. And 35 by 10 is also 3, right? What about 40 by 10? That would give us 4, right? But the cost of, for, okay, say we get this number of operations. This is this. We need two operations. Cost for the services, operations needed into scaling cost. We sum all costs of a service. If the total cost is less than or equals to budget, the function returns true, else returns false. A binary search set a range low equals to 100 and high can be a very large number, 10 per 18 to be safe. Mm, to be safe, we loot while low less than or equals to high. While low less than or equals to high, we pick mid equals to low plus high minus low by 2. If can achieve mid is true, if low is less than or equals to high. Mhm. And low plus high minus 4 by 2. If can achieve mid is true. If it is true, go to the right, meaning mid plus 1. Mid is possible. We store the potential answer equals to mid, and go for the mid plus 1. If it is false, go to the left, which is mid minus 1. Mm, we can achieve um, throughput scaling cost, throughput scaling throughput, and the scaling cost, and the budget, and the target throughput. Total cost needed is 0, and at the end we return if it's less than or equals to budget. For size, I'll report if throughput is less than target. Operations needed would be this much. Um, and cost for this service operations needed times scaling cost. Total cost needed is it plus this. Okay. If total cost is greater than false. What is the maximum minimum throughput achievable for a budget? Mm. One 18 is a safe upper bound and competitive programming. Using 2 times 10 per 18 for safety. LL max achievable throughput is 0 as of now. is 0 always achievable? This is the solution described by it is intuitive, but an Encom pointed out its runtime depends on the budget, which can be bad. The logic is that system throughput is always limited by services with the current minimum throughput. Therefore, together bus users will always spend our money upgrading the weakest link. We use a minimum priority queue mainly to keep track of which services is the weakest. The queue will store pairs. The queue will store pairs to senders, current throughput, and index. This way, the service with the smallest throughput is always at the top. Main heap or minimum priority queue has the smallest element at top. So I have a queue with uh, output throughput, comma, index. We also need to store the initial throughput and scaling cost in array as we can access them by index. Initial throughput. We need initial throughput and the current throughput. Hmm. I will push all services initial throughput of I comma I into the main head while budget is greater than 0. Get the weakest link from the top. Auto current top index dot p top auto this equals to pk dot top priority q dot top q, but I thought q had a friend, right? Why is it top? That's yeah, explain priority queue again. What is a priority? Think of a regular queue like a line at a store. First thing first, that a variety is different. It is it's a container where every element has a priority. When you pop an element, you always get the one with the highest priority, regardless of when it was added. In Silvers was this implemented using a data structure called max heap. This means top always gives you the greatest element. Min heap gives you the minimum element. Top push pop. Using steps, priority and this. Fuck, it's 3. I have exam at 7, so I'll be leaving at 6. So 3 to 4, 4 to 5, 5 to 6. I have like only 3 hours left. I gotta do this shit quickly. But I know there is another practical question as well. So me learning this properly would help me further as well. But I gotta just learn everything quickly. So I gotta increase my speed. Access the top element as stock. Greater and It's called pairs. Uh, using pi equals to using pi as pair of int comma int. This creates a min heap for pairs, comparing them by their first element. Min heap for pairs, comparing them by their first element. Choose for pairs, com- their first element. Extra, extra, this cost and the node. Minimum pair would be push is login, push, pop, chop, login, login, just looking is one. Alright, ask yourself this one question. Do I need to repeat, do I need repeatedly process the smallest or largest element for a collection that is also changing? If the answer is yes, you probably need a priority queue. The kth largest slash smallest element problem. Find the kth largest element in a stream of numbers using min heap of size k. Find the kth largest element in a stream of numbers using min heap of size k. When a new number arrives, if it is larger than the if, if it is larger than the heap, stop the smallest of the k largest elements, pop and the top and push the new number. Is your kth largest element. Greedy problems. Choosing the best next step. Merge and sorted files. Merging two files of size A and B cause A plus B. Two files. of size A and B costs A plus B. Find the minimum total cost. Put all file sizes in a min heap repeatedly. Pop the smallest. Shortest path. You always want to explore the node that is currently the closest to this slot. Heap storing distance node index is perfect for this. Shortest. Relations meeting rooms to given start and end times, find the minimum number of rooms needed. Solution sort by start given meeting rooms to given start and end times. Find the minimum number of rooms needed. Find the minimum number of rooms needed. Sort by start time. Use a min heap to store the end times. Sort by start time. Use a min heap to store the end times of meetings currently in progress. For each new meeting, check the top of the heap if the meeting starts after the earliest ending. If the meeting starts after the earliest ending meeting finishes, pop that end time, then push the new meeting to this. The size of the heap at its peak is your answer. That's a super common mix up. It's actually the reverse. Or to make it min heap, default is max heap, largest at the top. If you write greater int, tells the queue to use this operator for comparisons. This means an element A is less than B. If A less than B, the setup results. Spare heap in min heap. If we create a min heap pair like priority queue pair of int greater int, it will sort by the first element of the pair smallest first. If the first element at time, oh, I think I cleared it, but let me just look up the solution now. Max throughput is this thing. Okay. It's 3, 2, 1. Let's go. How much time do I have left? I have 2.5 hours left. So we have a priority queue that to main heap priority queue. We use greater than for main heap. Okay. Initialize the heap with all the services. All right. I'm gonna push all of the throughput, initial throughput values and their indexes because with that index we can get their costs afterwards later. Yeah. And also their initial costs as well later. Keep upgrading the weakest link while we have budget. So while budget is greater than 0, we have budget equals to budget. And while budget is greater than 0, get the service with the minimum throughput. Get the service with the minimum throughput. Okay. Service is pair of end comma end weakest equals to eq.top current throughput and index is this cost to upgrade equals to cost to upgrade equals to scaling cost of that particular index. So now we have the correct current value and cost to upgrade. And now check check if we can afford this upgrade or not. If budget is less than cost to upgrade, if our budget is less than even upgrading it, then fuck it, we can't upgrade it, so we are gonna break. And we are gonna break and then return that. Oh no, we push the weakest one and break, which is gonna be our answer because we were not able to increase it. So that would be the minimum, right? So we had to push it. We just can't break, or we could just return that answer as well. But we are gonna return here, so we can just break it. Budget minus equals to cost to upgrade. From the upgrade. Budget minus equals to cost to upgrade. We upgrade it once and then LL near TP equals to LL near TP equals to current throughput. We are just increasing it by once. If you can do it by once, We are gonna do it. If we can't, then break and then return the maximum top one, which is the minimum pair of int min heap, which uses greater int. Oh my god. And n is the number of services, b is the total number of upgrades we can perform. In the worst case, scaling cost for all services is 1. This means b could be equal to budget. I'm learning all this because I can't be solving all of the questions, right? But if I get a similar question which uses parity cube, through an example, because I went through an example, I'm learning all of the intricacies as well. Alright, that was one question. If one question is out of the way, let me get the next question, but let me first hide the screen. That was the first question, and now we go for the next question. Any segments are given. Any segments are given, each segment. Okay. Segments are given. Brother, the smart brother, and brother. Where is perplexity, brother? Mhm. If we can do it, then we can see. Okay, let me read the question. So this was n segments are given. N segments are given. Each segment is start index and end index. Okay. N segments are given. Return an array with how many other segments each segments intersect. What the fuck does that mean? Okay. We have n segments, start index and end index. Okay. Return an array with how many other segments each segments intersect. Return an array with how many other segments. Yeah. So we have, so is this question we have from start and to end is written on array with how many other segments each segments intersect. Each segment with how many do they intersect? So let's see how Gemini did. This looks cluttered. So should I just reduce the clutteredness? This is Perplexity. This is Gemini. This is WhatsApp. This is these questions. This is Quilpa and this is this. Alright. Let me go to the washroom and quickly come, bro. I mean, pause. Go ahead. You get it, right? after searching through um, thoroughly, here are the closest and exact links to the movie. Closure structure given n segments, count intersection. Segment intersection algorithm useful which maximize the task is to find the maximum number of segments that can be selected from the given model. So type the word. You would sort all intervals by their left endpoint L. Then you iterate through these intervals and this is any true to correlate how many intervals you've already seen that have I've actually not yet solved the trees question. I'm gonna do it later though, because I have Microsoft online assessment in like 2 hours or 3 hours. I have Microsoft assessment in like 3 hours, so I'm preparing for that. I have some previous year questions, so I'm going through them. Right now I'm going through these two questions, which were asked in another universities, which are Microsoft questions here. No, I've not done that trees question yet. Nested intervals, this is a 2D counting problem just like yours. You will sort all intervals by the sort all intervals by the left endpoint alone. Then you iterate through the sorted intervals and use of a bit tree to query how many intervals you've already seen. You iterate through the sorted intervals and use how many. Then you iterate through the sorted intervals. Use a Fenwick tree to query how many intervals you've already seen that have a right endpoint. Is the order. The correct solution with C++ code explained clearly in a structured manner. I don't know it should yet, so consequences solid then future and this question as I might test which is 120 minutes. Oh, what is the second question? This is a standard problem, but a great example of the required technique is on Codeforce's this problem is counting inverse pairs, but uses the exact same geometry logic you would need. Alright, I found the exact problem you're describing the okay, let me just read the question. An array is given, an array is given, an array is given, okay. We can make an operation this is the second question which was asked in Microsoft recently. So an array is given, okay, we can make an operation xy which will convert all x's to y's. An array is given, we can make an operation xy which converts all x's to y's. Minimum number of operations to make the array palindrome. N is less than 10 power 5. These are questions, okay. An array is given, we can make an operation xy which, what is it? I don't want to leak nothing, so 1 second. So this is the second question that I'm working on right now. Is when we can make an operation xy which will convert all x's to y's. Minimum number of operation to make the array palindrome. Okay, this looks so easy. I don't know why this question was asked though. It's a classic graph problem disguised as an array problem. Actually, I didn't know that. Array problem we solve it using a disjoint set union data structure. I have no idea on disjoint set, but I'm gonna learn it anyways right now. Disjoint set union data structure. A disjoint set data structure, also called a union find data structure or merge find set, is a data structure that stores a collection of disjoint non-overlapping sets. Okay, it has non-overlapping sets. Okay. Equivalently, it stores a partition of a set into disjoint subsets. We can consider it as a big subset which has a lot of subsets, and now these subsets also is stored in our disjoint set data structure. Okay, it's a data structure that stores a collection of disjoint sets. So it's like disjoint set data structure stores the subsets of a set, a big set. Okay, set equals to a partitions of a set into disjoint subset. It provides operations for adding new sets, merging sets. It provides operations for adding new sets. We can add new sets to it. and then merge sets, replace them with their union, that is, and find a representative number of a set. I don't know what that means. Find a representative number of a set. The last operation makes it possible to determine efficiently whether any two elements belong to the same set or different set. Alright. Whether there are several ways of implementing designs in practice, they are often identified with a particular design. Okay, I think this is too much. Insert and let me just get into it. The logic is iterate from the outside of the array you have a test in 20 minutes. Let's be fast and clear and strike with this problem has a classic n-log n solution. The simple O and square solution checking every pair is too slow. Chemically also called as a binary index tree is not strictly the only way, but it is standard and the cleanest way to solve this is n-log n time. I'll teach you what you need to know right now. Oh, this does not look that bad though. I thought it was gonna look way uglier. What it does, a binary index tree is not strictly the only way that, okay, binary Fenwick tree is binary index tree. Fenwick tree is called, fuck, I have very less time right now. Okay, it's 4 right now, 4 to 5, 5 to 6. I have like only 2 hours left. What it does, binary index tree, Fenwick tree or binary index tree is a data structure that acts like an array but can do 2 operations very fast. It acts like is a data structure that acts like an array but can do 2 operations very fast and a binary index tree is not strictly the only way, but it is the standard and cleanest way. Strictly the only. Okay. A binary index tree is a data structure that acts like an array but can do 2 operations very fast in log n time. Update index, value, adds value to the fuck? Do I have what it takes to learn Fenwick tree and then implement it in my exam? I think so. So I'm gonna learn it. Chemical cost operations update index with the value adds while to the element at index. Buddy, this is O of 1 in array, right? So why do you even need this? Here's the next one. It's the sum of all elements from index 1 up to index. Here is the minimal code you need. We use one-based indexing. Our array indices go from 1 to n. Vector struct Fenwick tree. Vector int bit int n. Here is the minimal code. We use one-based indexing. Our array indices go from 1. BIT binary indexed tree. Okay, vector int binary indexed tree. Int n. Initialize tree with size and all zeros. Fenwick tree of int n equals to n. Dot assign. Why didn't you just take n over here, but okay, maybe not to get confused with this. Initialize tree with size and all zeros. What is size and but initialize tree with size n equals to n, and then bit dot assign use n plus 1 for n plus 1 for one based index. Bit dot assign n plus 1 non-zero. Bit dot assign, okay. Adds value to index idx. Void update int idx and int value adds value to index idx. For int idx idx less than or equals to idx plus equals to idx and minus idx. Bit of idx plus equals to y. The fuck is this? idx plus equals to idx. Was it initially 0 though? No. And minus idx. I don't know, I'm gonna just remember it right now. Idx plus equals to idx and minus idx. Okay. We have to add something to the idx, that is to go through the loop. That is idx and minus idx. Okay. And gets the sum of the range 1 to idx. To get the sum of the range 1 to idx, int query int idx, int query int idx. Query int idx and sum equals to 0 for the same thing, and sum plus equals to get sum of the range 1 and idx. Is your sum is gonna be 0 and you're gonna go through the same loop, but you're gonna go from reverse this time and add bit idx to our sum, and we're gonna subtract the same thing, and while it's greater than 0 not equals to the return sum. That's it. You now have the tool. The solution logic: we need to find the number of segments j that intersect segment I. We need to find number of segments j that intersect segment I. That intersect segment I. Intersection segment j intersects segment I if this thing. If L less than or equals to R for I and j less than. Counting with binary index trees, we can find this We can find this count in one elegant step. Count all segments J that start at or before Ri. Count all segments J that end before Li. Counting all segments that start at or before Ri. What we need is Lj should be less than Ri. And Rj should be greater than or equals to count all segments J that start at or before Ri. Count all segments J that start at or before Ri. Okay, we need to include these, so you're gonna add those. And you have to remove something. Count all segments J that end before Li. What if Lj was greater than Ri and Rj was less than? Then that would mean it is more than intersecting, which we do not want, right? So we have to erase it anyways, okay. But we did not add it in the first place, so why are you gonna erase it though? I have a little bit doubt here, but count all segments J that start at or before Ri. Okay, I get it. Count all segments J that end before Li. Total and this. This works because count one gives you all the segments that start early enough to possibly intersect, gives you all the segments that end too early to possibly intersect. That then leaves only the segments that intersect. This count will include segments I itself. So we subtract one at the end. Okay. The problem, large coordinates. Oh. The coordinates start index and end index can be huge 10.9, but n is small 10.5. We cannot create a Fenwick tree of size 10.9. Solution: coordinate compression can be huge 10.9, but n is small, like 10 power 5, we can't create a Fenwick tree of size 10 power 9. Solution. Coordinate compression. We replace the large coordinate values with small indices, where m less than or equals to 2, and we only care about the relative order of the endpoints. Collect all 2n endpoints. Collect all 2n endpoints. Li for all I into a single vector all coordinates. Sort all coordinates. Remove duplicates. Now we can find the compressed index for any coordinate value by finding its position in all coordinates. Damn, this has layers to it. Coordinate compression. Collect all 2n endpoints into a single vector. Sort them, remove duplicates. Now we can find compressed index for any coordinate value, finding its position in all coordinates. Now I think it is not reasonable to solve this question in the exam because I'd had to learn this. Which I kind of understand a little bit, but all coordinates, segments. Alright bro, I think it's gonna be... I'd rather solve this question. The goal, let's be fast and clear and concise. Goal, make the array of palindrome. Palindrome reads the same forwards and backwards requirements. That means a of 0 must equals a of n minus 1 and so on. Operation convert x, y. Changes all x's in the array to y. Okay, I get it. But what's the question though? Can we make an operation x, y converts all x's to y? Minimum number of operations to make the array palindrome. Which are not equal, but then they might mess up the other ones, right? Operation convert x, y, changes all x's to y. So suppose this is written n equals to 5. So we need 1 equals to 4. And we need a1 equals to a3. We need 2 equals to 1. The 3 in the middle, so it's fine. The groups from 1 equals to 4, we know 1 and 4 must be the same number. Okay. From 1, we know 2, 1 must be the same number. By transitivity, if 2 is equals to 1 and 1 equals to 4, then 2 equals to 4. All three numbers must be if we make something equal over here, convert all this to this, and then convert this to this. By transitivity, if 2 equals to 1 and 1 equals to 4, then 2 equals to 4. All three numbers must be the same final number. They form a group or component. Counting operation. To make the group 1 to 4 all same, we need to convert 2 of them. For example, convert 2 to 1 and convert 4 to 1. This is 2 operations. A group with k unique numbers, needs k minus 1 operations to make them all the same. The problem, we need a way to find these groups. And count the operations. This is a classic connected components problem, and disjoint set union is the perfect tool. Quick DSU primer. What it does for it to already. What it does, it tracks. It tracks which group or set an element belongs to. What it does, it tracks which group or set an element belongs to. It is perfect for merging groups. Okay, it is perfect for merging groups, and it tracks which group or set an element belongs to. You only need 2 functions, find and unite. We use an array parent You only need 2 functions, find and unite. We use an array parent where parent of I stores the parent of I. If parent of I equals to I, then I is the root of its group. The fuck? We use an array parent where parent of I stores the parent of I. Mm, if parent of I is I, then I is the root. Okay. Parent Maxwell Raju. That's a great question, especially when you're in unfortunate situation you have a bit in DSU in the STL like map. In coding tests, people almost always write their own or they copy paste abbreviated on the other side. Since you can't memorize the whole struct right now, don't try to. Just focus on the three ideas. The code is just a translation of them. You can't memorize the whole struct right now, don't try to. Just focus on the three ideas. The code is just a translation of them. Your minimal DSU code. Here is the absolute bare bones code. You can write these functions at the top of your file. The inside main function, you just need to set it up once. Forget the syntax, just remember this logic. The array. We have one array parent of I just points to another number. Find I. Who is the boss of I's group? Who is the boss of I's group? Just follows the parent pointers up to the chain until it finds the number that points to itself. That's the boss. Unite IJ. Merge group I and group J. It finds the boss of I and the boss of J. Then it just makes one boss point to another. That's it. Merge group I and group J. It finds the boss of I and boss of J. Then it makes one boss point to the another. That's it. The whole group is now connected. Server once. I think DSU is relatively easier to use, and what are its implementations? I don't know. Just this question. I don't know. Should I just write it down and then maybe? Assume that I have all of the structure for DSU, then what should I do? The key insight in this is the minimum number of operations is exactly the number of times we successfully merge two different groups. The minimum number of operations is exactly the number of times we successfully merge two different groups. Why? A group of k numbers like this needs k-1 operations. The DSU unite function will be called k-1 times to connect all k numbers into one group. Let me just search if I have more of Microsoft questions. This must be connected. Okay. Just when you check this and this, you are saying these two numbers must be connected. So you add an edge between these two nodes. Build the graph. You loop from I0 to n by 2 and add all the edges. You end up with a graph that might have several separate islands of connected numbers. These are called connected components. Count operation. You use a visited array and a standard DFS to explore each island. When you start a DFS on new unvisited node, you found a new island. You count how many nodes k are in the island. An island with k nodes needs k minus 1 operations. Island with k nodes needs k minus 1 operations. Island with k nodes needs k minus 1 operations to make all its numbers the same. So final answer is the sum of k minus 1 for every island you find. Is it really that conceptually? Maybe if you're already comfortable with DFS and graph theory, incur more code, more complex to set up. You would need adjacency list to store the graph. Example this, a visited array, a recursion DFS. DFS, how do you do DFS? BFS was to go through all of the elements and then store the neighbors and then keep storing them in a queue and then visit them, and that was BFS. And DFS, how do you do DFS is a recursion call. You call DFS of a node with all of the things needed, and then for that DFS you visit it, and then probably add to our answer. Let me just see one second. DFS, you visit it, add it to our answer, and then do DFS for all of its nodes. all of its adjacent nodes which are not visited. And then finally we'll get the traversal. But how do you do the islands though? Number of islands is the very next question. Traverse the grid. If not visited in an island, start a new traversal. Okay, at all the starting points, you do a traversal, and how many times you would do the traversal, that would be the number of islands, right? And if all of it were connected, then that will be only one traversal, so that would be all of it would be connected. You're right, if your computer is on excellent and perfect way. It's 5 p.m. right now. I only have 1 hour left. Now, just look up some past questions as well. There's like nobody helping over here, but given an array n find differences of pair of its subsequences. start off with this. Given I'm gonna go get some water. I'm low-key stressed out right now. I'm low-key stressed out right now because I could have done all of this previously, but I'm doing this at the end time, so yes, I just filled my water bottle. I have only 1 hour left. Huh. X snoozed X. What does that mean, bro? Um. Anyway, okay, you're right if you're comfortable with DFS. If you're comfortable with graph traverses, DFS is an example of what you need to get to solve this. The very logic is very clear. It is built on the problem, the solution, and the core problem and logic notes every. Array A of I, when the array requires A of I to equal A of n minus 1 minus I, we draw an edge between the node this and this. This edge means these two numbers must eventually become the same value. Alright. Connected components. But the thing is, okay, we are doing that on the edges, not the indexes. Okay, the values, not the indexes. Okay, connected components. After we add all the edges from the first half of the array, a graph will be. Why do you say only first half of the array though? What about the rest half? Maybe they might have a connect. Okay, no. Okay, these should be connected to these, so this and this should be connected, right? I get it. So we only just need to do till half of it. Our graph will be set on set of islands. After we add all the edges from the first half of the array, our graph will be a set of islands. These islands are called connected components. Every number node with a single island must become the same final number. The fuck? Yeah, it should become, so it will be k minus 1 for every single island, right? Counting operations, an island with one node, like the middle element does, needs 0 operations, alright? An island with k nodes needs k minus 1 operations. For example, if we have a component this, we'll have 3 operations or 2 operations. And we can make all of them to 1. Our goal is to find all of the islands, count the number of nodes in the islands, and add k minus 1 to our total answer. DFS for DFS is to be used to explore these islands. We'll have a visitor array to make sure we don't count the same node or island twice. We will loop through all possible numbers 0 to max value. I don't get that. We'll loop through all of the possible numbers. This. If we find a number I that we haven't visited yet, it must be a part of a new island. Don't we have to just do it till it don't matter though. If we find a number I that we haven't visited it yet, be a part of a new island. We haven't visited, it must be a part of a new island. We start a DFS from I. DFS will explore every node connected to I and count how many nodes are in the island. Let's say it says component size nodes. We add component size minus 1 to our total operations. We continue looping until all members have been listed. That's a good code. Okay, let's look at the actual code. It looks simple. It doesn't look that complicated though. What's the sound? It's just water reminded you. Bro, X knows X. Do I know you? Like, or no? It low-key better if I don't know you. Because I kind of feel weird if somebody that I know watches me, I guess. No, I'm not that weird though, but weirded out, but yeah. We'll have a listed array that I can int main n vector a of n. We took the vector maximum value equals to 0 and I equals to 0. Wait a second. The values don't have to be 0 to n, right? They they can be anything, right? But how the okay. You find the maximum value and also take in all of the vectors elements. Initialize graph and the listed array. We need them to be big enough to hold all numbers up to max value. Adjacency matrix, adjacency vector, adjacency list, resize max value plus 1, and visited dot assign max value plus 1 equals to false. Till then, let me look at an easy question over here at square point. At Russell Clause, maximum of minimum difference of all pairs from subsequences of given cells. Oh, is this the same question? Okay, this question, I have to definitely do this one. This one and I guess this one are the same, I guess. Okay, it looks not that complicated, so I gotta do it quickly. Palindrome extension, is this the same question? Remind the maximum number of palindrome extents. Oh my fucking god, bro. Oh my fucking god, bro. These are the exact same questions that were asked in Microsoft, so I gotta do all of these. How many are there? I got only 1 hour left. So, in 10 questions, okay. 12 questions, I gotta do them quickly, bro. That's a very sharp observation. You're right, the confusion it's a key point. No, it doesn't mean all the numbers 0 to max value are in the array. You're correct. That is not the case. Here's the idea. Think of adjacency and listed array like being a big set of mailboxes. Number from 0 all the way up to max value. Let's use an example. A is this, n equals to 5. The values are these. the unique values are these. Max one is this. When we do adjacent of this, we are creating adjacent the resize 81 gives us 81 empty list mailboxes indexed from 0 to 80. Okay, share max value. Okay, we are only going to use the mailboxes for the numbers we actually have. Most of the mailboxes, these will stay empty forever. We just ignore them. When we loop I equals to 0, compare a of 0 value 10 and a of 4 value 10, 0, 10 and a of 4, 10, we go to the mailbox adjacency of 10 and add an edge to its surface. Doesn't change anything. When we loop I equals to 1, we compare a of 5 to a of 3, which is 5. Doesn't do anything. Is never given any edge because it's the middle element. So we have to just do till n by 2. Okay, so you are correct, you are not using the max value. We're just creating an array big enough to use all the values themselves as indices. It's easy way to code. We don't have to remap the numbers again. So we resize them and listed array all false. Build the graph, loop through the first half of the connected pairs and connect them and connect pairs. And value left equals to this and right equals to this, and value of left equals to pushback of right, value of right equals to pushback of left. Okay, we got this. And total operations equals to 0. Now we're gonna find components and count operations, loop through every possible number node, and I equals to 0 max value. Okay, go through all of these. No fucking way. If we find a node that is not visited, it's a new island. If it is, we also need to check if it's actually part of our problem. That is, it was an array. We can check if it has any edges or if it has any visited as part of another component. If we find a node that is not visited, it's a new island. We also need to check if it's actually part of our problem. That is, it was in the array. We can check if it has any edges or if it was just visited as a part of another component. Easiest way, if it is not visited, start a search. If it is not visited, in component size equals to 0 dfs of I, component size. If it is not visited, in component size equals to 0 dfs I, component size. dfs of I, component size, and then we visited component size. We are in a component, new component. We are in a new component and we are gonna do DFS on it. So we're gonna visit that node and then add it to our size. add it to a slice, and then go through all of it, and then call DFS on all of its um, adjacent neighbors which are not visited. Alright, that looks good. Okay, and then we keep that component size and then return the count, and then we add it to our total component size again, and then we get the total operations at the end. That's a fantastic question. You heard a key detail about how this graph is structured. Your 100% character graph only has nodes for values that are actually in the array. Oh my fucking god, it's 520, bro! It's 520 already. Graph only has nodes for the values that are actually in the array. The other numbers between 0 to non-values are like empty boxes. We create a space for them, but we never put anything in them. And it's so cool to find out when the when the loop hits the number I that's not in our array, like I equals to 0, and thus instead I will be false. First will run. It finds no neighbors. This is yay, that's a clever idea. Let's trace the logic we create a visited array. It's a great way to skip irrelevant numbers from the right start. The surprise will be irrelevant and answer is just a different way of handling problem, right? We don't care about it's no difference. Okay. So the question was The question was, what was the question? We have an array we can change from x to y, but we have to change all of the x's to y's. Mm, hmm, 520. What the fuck are you doing DFS without visited um, or anything? Okay, Western and adjacent are global. Alright. Okay, this is done. This is it. This is done. Given a sorted array and an integer k. Given a sorted array. నువ్వు టెస్ట్ రా ఇచ్చావా? కానీ షార్ట్ లిస్ట్ వచ్చింది. చాలా మంది షార్ట్ లిస్ట్ అయ్యారా? Maximum of minimum difference of all pairs for subsequence of given size. Aggressive cows. Um, is it actually aggressive cows are okay, given in India? Oh, this is a 7 minute cover. 7 minute video. I think I'm better off learning around my own. With 440 students overall giving our Microsoft exam. We gotta be tough. Tired. We can. Let me read this question first. Given sorted array and an integer string. Okay. We have a sorted array and an integer string. Among all the subsequences possible from the array of size k, among all the subsequences possible from the array of size k, return maximum of the so we need a subsequence of size k. We have to return maximum of the minimum difference among the numbers in all subsequences. Array is this k equals to the all subsequences possible are these. Minimum difference is this one. return maximum of the minimum difference. We have to return maximum of the minimum difference. Maximum of the minimum differences is 3. With the fourth card, you're gonna do that. And for the minimum difference should be maximum. So, minimum should be further away. How are you gonna do that? With binary search. I don't know. I wanna spend time, but I don't think I have time. In an array norms of size n, okay, which denote the position of stalls, and an integer k which denotes the number of aggressive cows. Assign stalls to k cows such that the minimum difference. Assign k cows. We have stalls, array of size n, and an integer k, which denotes the number of aggressive cows. Okay, these are the aggressive cows. Assign stalls to k cows such that the minimum distance between any two cows is the maximum possible. Such that minimum distance between any two cows is the maximum possible. Find the maximum possible minimum distance. The maximum possible minimum distance. Might as well was the solution.
So today's problem will be aggressive cows. But before moving on to the problem, I've covered up binary search on 1D arrays, where we did binary search on sorted arrays, rotated sorted arrays, and similar to that. And then we moved on to binary search on answers, where most of the problems were find the minimum of something or find the maximum of something. It had just one term, find min or find max. So the problem that we're going to solve today will be aggressive cows. But before moving on to that, I've covered up binary search on 1D arrays, where we did all the problems on sorted arrays, rotated sorted arrays, right? After that, we moved to binary search on answers, where we did all the problems where we had to figure out find min or find max. Now we will be moving to the other pattern of binary search on answers, where we'll be asked to find min of max or max of min. So we'll be doing around 4 to 5 problems on this particular pattern, so that this particular pattern sticks to your head. And the first problem on that pattern is aggressive cows. So what does the problem state? It states that you'll be given an array which does consist of n stalls. Now each of the stall coordinates is given to you. The first stall is at the coordinate 0, the next one is at coordinate 3, the next one at coordinate 4, the next one at coordinate.
How long does it take before me to finish this? Is it 20 minutes and that is 10 minutes? So if I watch it in 2x, it will be 15 minutes. So in 15 minutes, that would mean I would finish this by 6 p.m. Okay, that should be fine. Because I'm gonna get a deep understanding of this.
Coordinate 7, the next one at coordinate 10, and the next one at coordinate 9. Your task is to place 4 cows. If you take one cow, that one cow can go to either of any of the stalls. Any of the stalls it can go to. Your task is to place 4 cows in such a way that the minimum distance between any of the 2 cows, very important, the minimum distance between any of the 2 cows is the maximum. Might be confusing, but
between any of the 2 cows must be maximum.
it is of this pattern. If you carefully see minimum and then maximum, it is of that pattern. Minimum distance between any 2 cows is the maximum possible. And you have to tell me that minimum distance between any 2 cows is the maximum possible, and you have to tell me that minimum distance. It's confusing for the first time, but when you understand the question, you'll understand it in a much better way. So basically what it states is, these are the stalls given. If I have to maybe write the stalls in the correct order, the first stall is at 0, 3, and then 4, then 7, and then 9, and then 10. This is written down them in the sorted order. If I tell you, in place 4 cows, you'll be like, okay, cow 1, cow 2, cow 3, cow 4. This is one of the ways in which you can place cows, right? If I ask you, what is the distance between any of the 2 cows? You'll be like, the distance between them is 3, the distance between them is 1, distance between them is 3, and maybe the distance between them is 4, and maybe the distance between them is 4. So what is the minimum distance? among all the cows, any two cows. You can take C1, C3, C1, C4, C2, C3, any combination. What is the minimum? Can I say the minimum is 1, and there will always be between consecutive cows. Like if you just figure out 3, if you just figure out 1, if you just figure out 3, you don't need the distance between these two, because you're looking for the minimum. And the minimum will always happen to be between consecutive stalls. The minimum will always happen to be between consecutive stalls. That is the reason I sorted the stalls, right? So I know that the minimum is between this one. So if I place it like this, I'll give the distance as 1, and that's what they're asking you. What is the minimum distance between any two cows? That is what they're asking. What is the minimum distance between any two cows? You'll be like, okay, fine. Can I place something like C1, C2, maybe a C3, and maybe C4? I can. Even if I place it like this, the distance between this is 4. The distance between this is 5. The distance between this is 1. You can take this as well. You can take this as well. What's the minimum? That's 1. C3 as 1. C3 as 1. Can I place something like maybe a C1 here, maybe a C2 here, maybe a C3 here, maybe a C4 here, maybe. And if I figure out the distance, the distance between this is 4, between this is 3, and between this is 3. What is the minimum between any of the cows? You can take C2, C4 as well. What's the minimum? 4, 3, 3. What's the minimum? 3. So you can take 4 cows in any configuration you like. But the goal is figure out the minimum distance between any of the cows in that configuration. And over here it is 3. So the fact is saying, if you place it in such a way that this minimum distance is maximum, this minimum distance is maximum. So I have placed in this configuration, the distance I'm getting is 1. If I place it in this configuration, the distance I'm getting is 1. If I place it in this configuration, the distance I'm getting is 3. Which one will you prefer? You're looking for max. I prefer this because in this configuration, the minimum is very big. It's very big. So they are kind of at a distance. So I can take this configuration and this will be my answer. You can have other configurations as well. You will not be able to manage more than 3. Like you can also have something like maybe you can place one here, and he will say I'll place a C2 with C3 at 0 and at 10. So when I place this, the distance is quite big 10, and you can say that is the minimum distance. But the question is clearly stating there are 4 cows. You cannot get away by the distance is quite big 10, and you can say that is the minimum distance. But the question is clearly stating there are 4 cows. You cannot get away by putting just 2 cows. You have to put 4 cows, exactly 4 cows, not more, not less, exactly 4 cows. In placing 4 cows, whatever minimum you get, that is what you consider. So this is not a valid configuration. This is not a valid configuration. So you can have all the valid configurations, and the minimum distance that you see, whatever you get between any of the 2 cows, you have to maximize that value. So what is the first thing that we noticed? Since we require minimum distance between 2 cows, we just need the consecutive stall distances. There's no point in computing the farther stall distances because that will be big. I need min. So just computing the consecutive stall distances will make it work. The first thing that you do is this array will be non-sorted. The stalls are in non-sorted order. Just go ahead and say, can you please sort yourself? Can you please sort yourself because if I can place the cows, and then I can easily compute the consecutive distances. Can I say, maybe I can try out with 1. Let's try out with 1 and see if that is possible. I try to keep a minimum distance of 1. I will not place cows before 1 distance. Okay. What is the ideal scenario? Where should if I can place the cows and then I can easily compute the consecutive distance. Can I say, sort yourself. Can you please sort yourself because if I can place the cows and then I can easily compute the consecutive distance. Can I say, maybe I can try out with 1. Let's try out with 1 and see if that is possible. I try to keep a minimum distance of 1. I will not place cows before 1 distance. Okay. What is the ideal scenario? Where should you place your first cow? You will be like, sir, I can place it here, 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 or I can either place it here. In either of the stalls, the cow one can go. But what is the ideal scenario? Where should you put it? You want to put 4 cows. You want to put 4 cows. So like greedy, you will try to take the first place and then look for the distance increase. There's no point in putting it here because if you put it here, you'll not be able to place 4 cows. So the faster you put, the better it is for you because there's no cow before it. So there's no need to think of the distance. So that is why the ideal scenario will be to put the first cow at the first stall, which is whatever next is when you put. What's the next? I need to put the cow 2, and I need to make sure that the distance is 1. Can I put the cow 2 here? I can because the distance is 3. And trying to keep a minimum distance of 1. I can. So let's put the cow 2. Can I put the cow 3 here? I can because the distance is 1, so I can put the cow 3 over here. Right. Can I put a cow 4? I can because the distance is 3. And I can stop. Yeah, I can go ahead and put cow 6 as well. There's no need. I stop the moment I'm able to put 4 cows. So what I see is if I'm keeping a minimum distance of 1 also, if I'm keeping a minimum distance of 1 also, the distance is 3, it's 1, it's 3, it's still maintaining the 1. So I can, 1 can be done. 1 can be done with this possible configuration. So like 1 can be done. Okay, 1 can be done. But what am I looking for? I'm looking for max. So let's maybe take 2 and 6 also. That's fine. And C1 here. Yes. Again, I will always have the first stage. I want to place 4 cows. Can I place C2 here? Yes, because the distance is 3 and I need to maintain the distance of 2. So I can. Okay, let's see. Can I place C3 here? If I place C3 here, this is 1. Right now, I'm maintain the distance of 2. I have to maintain a minimum distance of 2. So I see C3 cannot be okay. Can I see C3 here? Yes, because I maintain a distance of 4. So I maintain a distance of 2 and this is also possible. Can I put this C4 here? Yes, because the distance is 2. I have to maintain a distance of 2. So apparently, after putting all the cows, I see that this is 3, this is 4, and this is 2. I'm violating. I'm making sure that each of the cows is at least 5 minutes. Okay. So the minimum distance is 2. Second, the also possible. Right, I'm looking for big numbers. So now I have to drive it 3. Now I have to drive it 3. Let's drive it 3. C1 goes here. Can C4 here? Yes, because the distance is 3. Can C3 here? No, because the distance is 1. Can C3 here? Yes, because the distance is 4. So C3 here. Can C4 here? No, because the distance is 2. Maintain 3. Can C4 here? I say yes. Why? Because the distance is 3 and that is 1. Why? 4 cows placed. Every 3 is also possible. Okay, 3 cows can be 4 cows. The configuration can be numerous. Maybe this is 1. Making sure that it's possible or not. Not looking for configuration. Looking for possible or not. Okay, so I may be 1. We're looking for max. Let's check if it's possible for 4 or not. So what I do is, I can press C1 here. Can I place C3 here? No, because the distance is 3. Maintain the minimum distance of 4 now. Not possible. Can I press C3 here? Yes, because the distance is 4. I can also maintain the distance of 4. Can I place C3 here? No, because the last 2. Maintain the distance of 4. Can I press C3 here? Yes. C3 goes here. Can I press C4 here? No, because the distance is 1. So if I maintain the distance of 4. If I maintain the distance of 4. I'm able to make sure the distance of 4 is maintained. But I'm not able to place all cows. I'm not able to place all cows. Not possible. Not possible. So what I'm observing, it's possible to 3 and after 4. Give me check 5. Give me check 5. There is no. Why? There is no. Why me check 5 is 10 minutes. Why me check 5? Because if I 4 is not possible. If I 4 you can't place 4 cows. I just say 11. I just say 11. I just say 11. It's not possible. So I figured this out. That we have to start from 1. 50, 1, 50, 1, 50 is the max value. Ask you, what is the max possible answer? Now remember one thing, the question clearly states that at minimum the question will always have cows. Like you'll never give 1 cow. Plus if you have 1 you cannot find distance between 2. At minimum, you'll always have 2 cows. That is what the question clearly states. Ask you, what is the maximum distance still which you can do? This is I think the where the number of cows and the worst, like the farthest configuration can be which is the minimum minus maximum. This can be maximum distance so that I can place a cow. Because when you're solving, you cannot check for the value of. You can go to the extremist case. Thereby you're saying the minimum distance so we know can be 1. And the farthest distance can be the max minus min. Again, this can be optimized as well. The range can be optimized as well if you start thinking, but that's not our main criteria. Main criteria is solve the problem. So we'll try to solve the problem in the least complexity. You can optimize this, but that will not be complex much. But yeah, I'm sure if I take this range, it will always be within this range. You also take something like 1 and 10 to the power 9. That's also correct. That's also correct. We are sure that the answer will be between. That's also correct. But yeah, we are very much sure that this range will make sure that the answer is between the range. After the range, can I like for I equal to something like maybe 1, and then we go until max minus min, and I press. What do we need to check? Can we place cows? If can we place, and we will pass on the I which has the stalls. Just make sure before this you just sort those stalls in the possible order. You just see this and pass on that. This is what you need. If this is making sure that you can place, I will also make sure that you pass in the number of cows because that is what you have to place. If it's able to place this much, we continue. We continue. If it is not able to place, if you notice nothing possible, 4 possible. So on 4 it will be 2, it will be false. Whenever it's false, you see it on the previous value because the previous value.
Can we place array with this much distance with this many cows?
The previous value was possible. That is the answer. Why? What about the time complexity? We need to figure out after we have implemented can be piece. If you can do can be piece, yes, pretty much. Let's quickly can be piece. If you can do can be piece, yes, pretty much. Let's quickly can be piece. So I have to implement and it will say can be place cows. And in these stalls, it will take the minimum distance that we maintain and it will take the number of cows that we place. Next, initially, I can keep the count of cows to be 1 because I know the first cow will always go at the first index. So which is like, where's the coordinate in this coordinate? Where the first cow will cows that you have to place. Can I say initially, I can keep the count of cows to be 1 because I know the first cow will always go at the first index. So which is like, where is the coordinate? You can say coordinate. Where is the first coordinate when the cow goes? At of 0. Because that is where you place the first cow. That's very much obvious that you place the first cow here. You have to look for the next. So you start from here. If cow 1 is here, you check can the cow to be placed. So what you do is, you basically start iterating from I equal to 1 and you go into the last value of the stall. Let's try to place it. If minus the coordinate in which the last cow is, wherever the last cow is, maybe you can call it as last, that will make much more sense. The last cow was at this. If the last cow, area of 5 minus last cow, is exceeding, at least maintaining that distance, can I say I'll be able to place this particular cow here? Imagine I have a distance of 4. And place a cow 1 here, and the cow 2 goes here and checks that the distance is 3. Not possible. Cow 1 is here, cow 2 possible. So now this is your last where it was possible. So you place one more cow. So can I say I have placed one more cow? I placed one more cow. And now the last cow was placed at this index. And now the last cow was placed at this index. And you can terminate it. At the end of the day, more cow. I placed one more cow. And now the last cow was placed. Cow 2 possible. So now this is your last where it was possible. So you place one more cow. So can I say cow here? Imagine 5 minus last cow is array of I minus the coordinate in which the last cow is, wherever the value of the stall. Let's try to place it. If array of I minus the coordinate in which the last cow is, wherever the last cow is, maybe you can call it as last, that will make much more sense. The last cow was at this. If the last cow, array of I minus last cow, is exceeding, at least maintaining that distance, can I say I'll be able to place this particular cow here? Imagine I have a distance of 4. And place a cow 1 here, and the cow 2 goes here and checks that the distance is 3. Not possible. Cow 1 is here, cow 2 possible. So now this is your last where it was possible. So you place one more cow. So can I say I have placed one more cow? I placed one more cow, and now the last cow was placed at this index. And now the last cow was placed at this index. And then terminate it. At the end of the day, if the number of cows, rather the count of cows, if you are able to place more than the required number of cows, that means you were able to place cows by maintaining a minimum distance. Thereby, you go ahead and return that it is possible. Or else, you say it is not possible. But you can say return false. And by the way, this particular statement can be done inside the folder as well, so that you don't do a lot of iterations. The moment you reach the number of cows, you say return. I don't want to place more cows. If done cows, return. And this is making sure that you keep a track where it was the last placed. Because in order to compute distance, imagine you're placing it here. If you compute it with C2, not with C1, that is why just keep a track where the last was placed. I hope this can be place makes sense. What now? If I ask you the time complexity, what is it? I'm going to the max minus 1. So that's like going to the max minus 1. Multiply by big O of n because you're going to the entire thing. Out of the space, that's a big O of 1.
This is 7 minutes, so it should probably take me 3 minutes to finish it, and I have 5 minutes to finish it, so I'm good.
So can we apply binary search? We can because we've already done similar problems. Remember, 1 was possible, 2 was possible, 3 was possible, 4 is not possible, 5 is not possible, 6 is not possible, and it will go until 10, which is also not possible. Why 10? Because the maximum that you can have is 0 minus 10. So it's not possible. We know a section where it's possible. We know a section where it's not possible. What are we looking for? By the way, this will be close. And what are we looking for? We're looking for the max possible answer. So go ahead and do it. You're at low, you are at a high. Can we perform the binary search? We can. So the lowest pointing to the first possible answer that is 1, and the highest pointing to the last possible answer that is 10. If I have to figure out the mid, it is 1 plus 10 by 2, 5.5. So the mid will be 5. Is 5 possible? No. So everything on the right is also not possible. Yes. So basically the I will move to this place. Perfect. I can omit this mid, and what I can do is I can also keep an answer variable as minus 1. Okay. Now what's the mid? The value of it will be 1 plus 4 by 2, that's 2.5. That's 2 as an integer. Is 2 possible? It says yes, it is possible. And if you remember, if it is possible, you're looking for max. So anything on the left will be small. So you store the 2. You store the 2. And you say, hey, can you move 1 place ahead? So you move to 1 place ahead. So you move to 1 place ahead. What is the mid? 3 plus 4 by 2 is 3.5. So the mid is there. Is 3 possible? And this is the limit. Is 3 possible? Yes, 3 is possible. 3 is possible. Your big answer to 3. And what you do is you just say that it is possible. I'm looking for max. Increase. So that quotient will go because on the left we get smaller values. So increase. And we're increasing. Where will it go? Lower will go 1 plus mid. So that's 1 place ahead. Next we try to find the mid. The mid will also be pointing to this. Is it possible? Not possible. If it is not possible, you eliminate. You eliminate right. And then we eliminate right. The I moves to 1 place before mid. So this is here. The lowest pointing here. And that's when you stop binary search. That's when you stop binary search. And on stopping, the answer is stored as C, which will be a possible answer. Possible. Yes, 3 is possible. 3 is possible. Your big answer to 3. And what you do is you just say that it is possible. I'm looking for max. Increase. So that quotient will go because on the left we get smaller values. So increase. And we're increasing. Where will it go? Lower will go 1 plus mid. So that's 1 place ahead. Next we try to find the mid. The mid will also be pointing to this. Is it possible? Not possible. If it is not possible, you eliminate. You eliminate right. And then we eliminate right. The I moves to 1 place before mid. So this is here. The lowest pointing here. And that's when you stop binary search. That's when you stop binary search. And on stopping, the answer is stored as C, which will be a possible answer. Read the answer. No, you haven't seen the playlist. You know how to find it. Yes, you know it. First one was at a possible point. I was at a impossible point. Possible in most cases. So we always put the possibility. Not possible. I will always put the possibility. So which one will be the answer? I is always going to be the answer. I hope that makes sense. So we need to do the next value answer. So we need to put any particular answer variable. And if any of those going to be the first, you know in most cases. So no will always go to the possibility. Not possible. I will always go to possibility. So which one will be your answer? I is always going to be your answer. I hope that makes sense. Some people like answer. So we don't need to store any particular to be your answer. I hope that makes sense. So no need to use an extra variable answer. So we don't need to store any particular answer variable. And for anyone who's watching my playlist from the first, he knows the polarity process. And if in case you're watching it for the first time, it's very simple. The low is pointing to have like possible case, the high is pointing to non-possible case. Binary search will make sure that it ends up at a not possible place, and this ends up at a possible place. It just changes polarity. Possible goes to non-possible, not possible goes to possible. Since we're looking for a possible answer, hence high will be my answer. Alright? So we just need to return the high. No need of storing any extra variable answer. Got that? So it's really write down the pseudocode. It's really super simple. I take the array, I take the number of cows. Yeah, that's it. I say low is 0, and the high will be pointing to max minus min, which can be written as f minus 1 minus of f 0. And I can say sort array comma array plus n. This is in C++. You can figure out as well, and then just disregard your method. And then what I can do is while low is less than or equal to high, what do we do? We figure out the min, because that is what we have to figure out the distance. And we say, can we place? We call the function that we have written in the research. We call the function that we have written in the research. Can we place in the array with the distance of mid and these many cows? If you can place, this is the possible answer. This is the possible answer. We need to store an answer, and we need big value. So look for the right half, because the right half has big values. Or else look for small values, because that's not possible. At the end, the value will end here, and then we return the high or the answer as well. Yo, the high or the answer, and then we return the function. This is how easy it is. This is the reason I prefer cycle linear search, because once you understand linear search, it's super simple to avoid big research. So what is the time complexity? Sorting at first, so that's n log n plus very linear search, so that's n log n, and the range is this. So goes to this multiplied with a big of n, because we only can be placed which takes a big of n. So this will be over time complexity. This so goes to this multiplied with a big of n, because we are calling it can be placed which takes a big of n. So this will be the overall time complexity. This multiplied with this plus the sort log n. And what is the external space? Nothing, big of n. So big of n is the external space that we use. So let's get back into the code editor and check out the code. By the way, you can figure out the C++ Java by the JavaScript codes from the notes in the description, and also you can find the problem link in the description itself to try it out. So run the exact same code, and I've just taken the conditional statement inside the for loop. The one you get the number of calls that you require. Stop. After if you don't find it, just return false. There's other thing. So I've written as 1. You can experiment and it actually increase the value of flow. The low can go to something like min of all consecutive negative differences. What do I mean by that? So go to this example. Not this one. Yeah, this one. So the difference between this is 3, the difference between this is 1, the difference between this is 3, the difference between this is 3, the difference between this is 1. So if you think the consecutive differences are, and whatever is the meaning of that, you can just change it to that as well. But I don't want to complicate it. You can think and trim down the range more as well, but that's not required, because the core of the problem is to solve it. Like if you're taking it 10 to the 9, then the interview might have an issue. If you're taking it like this, it's okay. He will not care that much. So yeah, you can write it down as well. But yeah, this one will be working fine in interviews as well.
Alright, so this is done. What's next though? What is next though? What is next? What is next? So, alright, this question is done. And now what is the next question? Given a vector of string, given a vector of string, oh fuck, it is 6 bits. What can I go to be in? Okay, given vector of string, strings. You got the exact same question. Alright, give it to me, bro. Give it to me, bro. You got the exact same question. Yeah, forget that. I think I should be fine. I'm gonna just solve this. I can just, solve this first and think about stuff later. Yeah, my face kind of looks fat. I gotta do running up the basketball, I guess. We need maximum palindromes after operations, okay? You are given a zero indexed string array words having length n and containing zero indexed strings. Nishant, 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 6 అయిందిరా. ఇంక 30 మినిట్సే ఉంది. సారీ 1 అవర్ ఉంది కానీ ఎగ్జామ్ 7కి 6:30కి వెళ్ళాలనుకుంటా. సిక్స్ ఫైవ్ అయింది. అంత నిద్ర వస్తుందా? నైట్ పడుకోలేదా? సీటింగ్ అరేంజ్మెంట్ వచ్చింది చూడు. రే ఒకవేళ సెగ్మెంటరీస్ ఇది అది అడిగితే నీకు వచ్చారా సెగ్మెంటరీస్ ఫెన్విక్ ట్రీ అయంతా? అదో నేనేమన్నా చిట్ తీసుకెళ్దామా అని ఆలోచిస్తాను నిన్న, కానీ అక్కర్లేదు కదా. ఉమ్.
Hey everybody, this is Lab.
ఎక్కడున్నా ఏం చేయలేమనుకోరా.
And then at the very end, if we, oh yeah,
అన్నీ 8 అబోవ్ వస్తున్నాయేంట్రా అన్నీ? రీసెంట్‌గా వచ్చిన 3 కంపెనీలు 8 అబోవ్. చూసావా నువ్వు? చూడలేదా? చూసావా లేదా అంటున్నా? అరే ఓన్లీ ఇంటెల్ ఏమొచ్చిందంటే స్క్వేర్ పాయింట్ లాంటి క్వశ్చన్స్ ఏమైనా అడగొచ్చు అన్నాడు కదా. రుగత్ కూడా అదే అన్నాడు. ఇంకా వాడు మనకేమొచ్చాయి పంపించాడు. నేను పంపించా చూడు అప్పుడు. మనం రాయలేగా ఎస్డి, వచ్చి క్వాంటే రాసాంగా, క్వాంటిటేటివ్ ట్రేడింగ్ రాసాంగా. అందుకే ఎస్డి టైం నా చెక్ చేసుకో కావాలంటే, ఇంకా టైం ఉంది కొంచెం. అవును. Then an integer denoting the maximum number of palindromes words. Okay. No. Redistribute all the letters freely among the words. Okay, that was okay. Calculate the frequency of each letter and the total number of matching letter pairs that can be formed from the letters. What the fuck? Calculate the frequency of each letter and total number of matching letter pairs that can be formed from the letters. Total equals to sum of each frequency by 2. Okay, now we got all the frequencies and how many we can pair, how many pairs of letters we have. We can greedily try making palindromes from word I with the smallest length. Okay, we can greedily try making palindromes from words I with the smallest length to words I with the longest length. For the current index I, we try to make words I a palindrome. We need we need this many matching characters, and the letter in the middle, if it exists, can be freely chosen afterwards. Okay, we can check if we have enough pairs for index I. If we do, we increase the number of palindromes we can make and decrease the. We can check can be freely chosen afterwards. We can check if we have any pairs for index I. If we do, we increase the number of palindromes. we can make and decrease the number of pairs we have. Otherwise, we end the loop at this index. The answer is number of palindromes we were able to make in the end. The answer is number of palindromes we were able to make in the end. ట్వంటీ 26 ఆల్ఫాబెట్స్ ఉంటాయి కదా నార్మల్గా. చాలాసార్లు నీకు ఎప్పుడైనా డౌట్ వచ్చిందా ఏదైనా ఎగ్జామ్లలో? అన్ని ఫాస్ట్గా రాసుకొని కౌంట్ చేసుకోవాల్సింది. మ్హూ. ఆ, అవునా? అవునా? ఇంకా 7 minutes లో బయలుదేరాలేమో కదా. ఓ ఫక్ రా 6:35 అయిపోయిందా? ఈ వాష్రూమ్ అంతా వస్తుంది, వెళ్ళాల్సిన అవసరం లేదంట. టాయిలెట్ కాదు, బాత్రూమ్కి వెళ్ళాలా? ఇట్లా చూసుకుంటుంది ఏమో.